Hi, my name is Kanti, and this is my team, Julio, Priyanka, Paul, and Kristen. We are the interns working in the Space Systems Academic Group, also known as the SSAG at the Naval Postgraduate School this summer. One of the projects we've been working on is the Cricketsat. The Cricketsat is a small circuit that transmits temperature data when launched into the atmosphere on a weather balloon. Our mentor, Dr. Newman, a former NASA astronaut, has been part of the SSAG for 10 years and is currently the chair of the department. He has directed many CubeSat and Cricketsat launches.
So what is the purpose of the Cricketsat project? Well, in particular, the Cricketsat project allows us to have a rapid way of demonstrating a number of concepts. In particular, the physics of a how-to balloon and some very simple electronics. And we combine that with a field exercise where we get the students together and we go out into the field in order to give them hands-on experience with the electronics, the how-to balloon, collecting data, a number of the things that are important in the laboratory.
A Cricketsat launch involves a planned launch and landing site, so we used the website habhub.org to predict the flight pattern our balloon would take. On the days leading up to the launch, we tested potential launch sites and parameters and chose a 645-gram Howie balloon as our launch device. The morning of the launch, we checked one last time to verify our launch parameters were still valid. Last but not least, since we weren't retrieving the Cricketsat, we left a note with contact information in the event someone should find it. On the morning of July 17th, we drove out to Veterans Memorial Park in Soledad, California, to launch the Cricketsat. When we arrived and began setting up, it was cloudy, but cleared up right before our launch time, just as we predicted. To give our Cricketsat some personality, we added some googly eyes and named it Chirpy, since the cricket chirps as it sends back the telemetry data. It was time to let Chirpy leave the nest, so we started filling up our balloon. Unfortunately, a manufacturing defect caused the balloon to pop prematurely, so we used our backup 618-gram balloon and a spare tank of helium. With our ground station receiver set up, we bid our last farewells to Chirpy and let him fly. We were able to maintain a visual on the balloon for almost an hour as it soared to more than 20 kilometers while using a telescope to track our receiving antenna on the Cricketsat. After we got all the data we needed, we headed back to the lab to analyze our results. The Cricketsat sends back a frequency that increases with decreasing temperature, so our data shows that temperature does decrease with rising altitude in the troposphere and remains relatively constant in the lower portion of the stratosphere. Overall, our launch was a success, and we had a lot of fun throughout the process. This project is the predecessor to a lab that the SSAG will be creating for its grad students to help them learn about circuit design and soldering, basic electronics and radio communication, structural design, and fieldwork. We are the 2018 NPS Summer Interns, and we are proud to be helping the SSAG in its efforts to pioneer the future of space exploration.